All right, everybody. Hello and welcome to the ACM at UC General Body Meeting 9. It's actually our 10th meeting. At the start of the semester, we decided to zero index our meetings because we thought it'd be cool. Turns out it's really hard to keep track of what meeting you're on. So we're actually on our 10th meeting of the semester, but it's 9 since we decided to zero index. If you didn't do attendance, I'd really appreciate it if you went to acm@uc.org/c. Like I said earlier, that's how we do voting rights. That's how we do member being on the website rights. And it also just helps us with knowing how many people come to meetings. So I've got a couple of reminders, which I've had, I think, every meeting so far this semester. You're being recorded, both on my laptop or the screen, and then we got a video camera back there. That's so that we can upload our videos online to our archive after meetings. And you can find us on YouTube. Sign in if you haven't, and then if you are interested in being on our website, you can go to our GitHub repo for our website and make a pull request to add yourself. We offer academic services, namely office hours, which could be tutoring, it could be hangout, it could be whatever you want it to be. 802A is our office, and we are in there. There'll always be at least one person in there from Mondays from 6 to 7 and on Wednesdays from 1 to 2. So if you have a quiz or a test coming up and you want to go talk to somebody about it, we're there. Hopefully we've got somebody who's been through that course or has taken it. So Slack, if you're not in our Slack, we have an ACM at UC Slack. You can find a link to the Slack on our website at acm@uc.org, or you can go directly to it, acmcincy.slack.com/signup. It is the way to talk to other ACM at UC general body members. We share tech news, we share releases of new cool platforms, and then talk about different things, post memes, all the good stuff. Revolution UC, if you haven't signed up for it, is our hackathon. It is March 3rd and March 4th. It's the big epitome of the computing community here at UC, so check it out. It's entirely free to attend. If you've never been to a hackathon before, that's perfectly okay. It's a great hackathon to make your first. It doesn't matter what level you are. If you are a beginner programmer or you're an expert programmer, you're going to have a good time. You get free food, you get to network with all of our awesome sponsors, which we've got a bunch of them. You can find them on our website. We've got fun mini events. We've got, you get to code. There are prizes for the best projects, and it's just a really fun event. And you can sign up for free at revolutionuc.com. And then maybe on our Twitter, there's a video of me talking about it, but I'm not going to play it because it's one of those things where you can't listen to yourself talk on video. So our next meeting is Thursday, March 1st at 6 p.m. in CRC 3250. That is 2 days before the hackathon, so we will be doing a Hackathon 101 meeting. So if you've never been to a hackathon before, it's a great way to come and learn a little bit more in depth what all goes on at a hackathon, what can I expect. We'll talk about all that, and then if you need a team or you need an idea, we'll do some brainstorming and team forming. So it's kind of just a hangout meeting. We'll talk about what goes on at Revolution UC and what to expect. So even if you've been to hackathon before, maybe you'll learn something, or you can at least come up with an idea or get a teammate, and if nothing else, you can enjoy free pizza. So that is all my updates for ACM at UC. As always, if you have ideas for ACM or you have questions, you're more than welcome to come talk to me after meetings. Email me. You can find my email on the website, or Slack me. My Slack, I'm always posting, so it's not too hard to find my name on there. So we are here today because we are doing an introduction to Docker localhost through MLH. I'm going to talk about what Docker is, I'm going to talk about what MLH is, and I'm going to talk about what localhost is. So to start off, I think everybody here is probably on UC Secure, but if you are not, maybe you're a non-UC student, you can check out UC Guest. There's no password for it, but you will need to authenticate through the browser. And then MLH, which I'll talk about what MLH is in a second. Would love it if you tweeted pictures of the event and threw those hashtags on it and added them. They'll like it or maybe even retweet it. And for my exec members, I need you guys to do that because they specifically requested we do. So who am I? My name is Kurt Lewis. I am the president of ACM here. I'm a fourth-year computer science student, and they wanted me to list my favorite programming language, and it's probably Python because there's anything, you can do anything you want in it except to be strong typed. So I'm hoping I can do a good job of leading us through this today. And let me know if you have any questions. Just throw your hand up, and I'll do my best to answer them. So I asked you to check in for ACM at UC, but I also actually need you to check in for MLH. And I'll talk about what MLH is in a second, but if you go to that URL, you can check in. I think they just want your email, what event you're at, and then they will use that to send you a link to the slides and a link to Docker resources as well, which I'll talk about in a bit. So I'll give everybody a second to do that. And if you want to flag me once you have, I get to eat pizza now. What is MLH? I promised I'd tell you what they were, and if you don't know, here I'm going to go. So MLH stands for Major League Hacking. They are an organization that helps student groups across the nation, and even in Europe too, throw hackathons. And they've kind of expanded their purview into doing these local hosts. Pretty sure the next slide is about what localhost is. MLH has helped 65,000 hackers create more than 12,000 projects at hackathons across more than 3,000 schools. So they are a pretty big organization. They help a lot of different student groups, and they're actually a big part of Revolution UC. They provide our hardware lab. They provide a lot of resources and support for our organizers as well. So MLH is a really cool organization with a cool mission. What is localhost? I guess there isn't a slide. So localhost is an initiative by MLH just to provide high-quality workshop content to student groups that want to throw events like this. A lot of the time we write our own workshops, but Docker is definitely something I didn't have the expertise on to write my own workshop or anything. So they give us this. They give us swag, which you will get the swag at the end of the workshop. It's stickers, and they give resources and connect us with Docker. Docker is going to send you some student resources. So we're going to do a couple of things. We're going to talk about what localhost is. I think we just did that. We're going to talk about what Docker and containers actually are. We're going to set up Docker. We're going to do a couple of runs with it, and then we're going to even do a web app with Docker. Oh, so there is a localhost slide. So what is localhost? It's doing these outside of classroom skills. You're not going to learn Docker in most of your classes here. And then it just fills the gap between school and hackathons. Gives us something to do as we build up to the next one. So the workshop goals today are to understand Docker and containers. We're going to download and run Docker, or maybe not, depending on the version you are on. And then you're going to build and run a container from scratch and upload a container to the Docker cloud. So once you leave, you'll have all the skills you need to go and build your first actual Docker application. So, like I said, they'd really appreciate it if you took pictures and shared your experience, and you could even take a picture of me and tweet it. They appreciate that social media presence. So let's talk about what Docker and Docker containers actually are. So Docker is a platform that helps developers build, ship, and run any application in any environment. And that's vague. We're going to break that down a little bit more in 2 slides. So what is Docker Inc? Docker Inc is the sponsor of the Docker project. They put the resources forth to maintain it and host these websites that host the Docker applications and things like that. And then they offer containers as a service. That's the way they get their funding, end-to-end platform, and then commercial tech support for enterprise level Docker use. So over 60% of Docker users are using their platform in production. So let's talk about what Docker actually is. But to talk about what Docker actually is, we have to do a little bit of background on web applications. So in the past, around the year 2000, you had these huge monolithic web servers that handled everything. They handled your database connection. They handled all the activities that were happening on your database server. So if there was an action that clicking a button did, these monolithic giant web servers handled that. They were written in Java and other large languages. But as we get kind of towards today, there's kind of been a movement towards what people call microservices, where you build a service that handles one specific functionality, one specific feature, and then connect those microservices together. So you might have a service for your database, a service for handling logins and things like that. And so what Docker is it lets you take those loosely those services and deploy them in a I'm losing the word I'm looking for, a redoable way. So you have many small servers. It's easy to make a change to a single one. It's not this giant change to a single service, and you have those microservices. So in a distributed application, you have a lot of different things going on that I was just kind of talking about: API endpoints, your database, your actual website, and your background workers. And then when you take that into the Docker service area, you can start breaking those things out of a single application and into their own little Docker container that handles only that one specific action. So a Docker container is not a VM, though in some ways it's helpful to think of it, but it is not entirely a VM. They share characteristics, but virtual machines in themselves are the entire operating system, the entire kernel running for you. They both provide, a virtual machine and a Docker container, an environment for applications to run inside independent of the host. And they're both easily movable. You can shut one down and switch between actual hardware, but they are different. And you can think of it as a house versus an apartment. In a house, each VM has absolutely everything you need, and it creates, if you wanted to create a new version of it, it would create everything you need again. But with a Docker container, it's more like apartments, where they contain exactly what they need to run their application, but they share underlying resources. So, Docker gives you the ability to build and ship and run your service or your web app in any environment, because in reality they're going to run inside of this Docker container, not on the host machine, and so that gives you that reproducibility there. So if you write an application that runs in a Docker container, you know it's going to run the exact same regardless of where it's running, if that's a Raspberry Pi, your laptop, or a production server. So, talked a little bit about Dockers and containers, and like I said, if you have any questions, raise your hand and I'll do my best to answer them. But let's talk about Docker Hub and then get into actually setting up Docker if you have the right operating system for it, which we'll talk about. So, Docker Hub is a registry for Docker images, and we're going to talk about what Docker images are, and you'll actually get a chance to create one in a few minutes. But you can think of it as kind of like GitHub is a place for uploading your repositories. Docker Hub is a place for uploading your images. So an image has a little bit more going on than a repository has. It's got that container and those definition of those resources there for you. So all of the images we're going to use in this workshop today can all be pulled down from the Docker Hub, and I'll show you how to do that. And so what they want you to do, and it's not a bad idea, is to sign up for a Docker ID. So if you go to, and you can see it's a little bit hard to read there, mlhlocal.host/dockerhub, it'll take you to the Docker Hub ID creation page, or you can just Google Docker Hub and click sign up. It's an easy process. Think of it kind of like signing up for GitHub, but instead of it being for Git repositories, it's for Docker images. So if you do that now, you'll need to remember your username and password for later in the workshop because we're going to log in. So I'll give everybody a second to do that. And while we do, does anybody have any questions? Cool. So go ahead, Pat.
So I created this with my non-UC account. Is there something that, should I have done with my UC account?
No, you can use any email you want to sign up for MLH or for signing up for Docker. While people sign up, if you guys don't mind, I will take a picture for MLH. Is Isaiah also taking a picture of me?
Oh,
You need action shots of, I guess, the screen too. So there we go. So if you don't sign up for a Docker ID, you'll be able to do part of the workshop, but not all of it. But you'll be able to do the whole thing if you sign up for a Docker ID, which this is the only thing you'll have to sign up for. It's a good chance to lock down your typical username. Anybody else need more time? All right. So once you have created your account and you've verified it using your email, you can log in and you'll see the welcome to the Docker Hub homepage. You won't have any repositories yet, but you're going to get one in a few minutes here. So let's talk about actually installing Docker. So if you go to these links, you can find instructions for installing Docker. But if you are on Windows 10 Home Edition, Docker won't work for you. So if you're on Windows 10 Home Edition or Chrome OS, I presume Docker doesn't work on Chrome OS?
not yet.
Not yet. So There is another option, and I'm going to use that other option today. So if you are on Linux or Mac or Windows 10 Pro and you want to install, go ahead and do that now. If you are on another Windows version, just hold off, and I will show you guys how you can do everything they're going to do with the exception of installing, and we'll do that in a second. And while you guys install, for those of you who are installing, I will switch how I'm presenting. Cool. So, for those of you who do not have a machine that can run Docker, so a Linux, a Mac, or Windows 10 Pro, what you're going to do is you're going to Google Cloud Shell. And all this requires is a Google account. It's entirely free. And you'll click the first link that comes up, Cloud Shell. And then once you've gone to Google Cloud Shell, and you've gone to the Google Cloud Platform page, and you're to this page, you're going to go up to the right corner up here, next to your picture, and you see console, and you'll click it. So the actual URL for that is console.cloud.google.com. And I'll pause here so while we give people a chance to get here, and for those of you who are on a supported platform and are installing Docker, you can do that. Cool, all right, we will get started. So, if you're on this page or you have Docker, what you're going to do on this page is go up here to activate Google Cloud Shell. It's a little thing that looks like a terminal on the top. And it is going to create a VM on Google servers for you entirely free. That is ephemeral, if I'm pronouncing that correctly, which basically means that anything you put in your home directory does save, but anything you put in your, any changes you make to the machine, if you install something or if you set something to run, it won't last because 5 minutes after you close this session, the machine's going to shut down, save your home directory, and exit. So this is really cool, good way to get on a Unix environment and try something out as long as that something doesn't involve long-term projects or changes. So if you're here, you can type help to double check that everything's working. You can see that I made it to the help page. How's Docker coming?
Yeah. Some weird issues in the browser. It's not Docker.
It's the browser?
It's not like the browser.
Yes. Zach, will you go back there and see if you can help? All right, then I'll well, they try and figure that out.
It sucks because you can't really tell the original. It's like a Christmas.
There we go. Good. All right. Anybody else need help? Very good. All right. So if you are here and you've got Docker installed, we're going to test your installation. So on the Google Cloud Shell, that means that you don't have to do anything because it's already installed. If you are on your own machine, this is where you find out whether or not it worked. So we're going to type Docker, which says invoke the Docker tool, run, which tells it we want to run a container, and then hello world, which is their container that says, hey, is everything working? So if you type out Docker run hello world, and I'll see if I can drag this up to make it easier to see, and then hit enter. You'll see it do a couple things, and then output some text that says hello from Docker. So I'll give people a chance to run that. If anybody doesn't get that message, either because you installed and had an error with installation or the Google Cloud Shell isn't giving it to you, again, just raise your hand and we'll send somebody over. So, last chance to flag me down. Okay, so the hello from Docker, it tells you a couple of things. It tells you that the Docker client connected to the Docker daemon, and then it didn't have the hello world app actually on your machine. So it went to Docker Hub and pulled it down. And then it created a new container from that image because your Docker, your hello world is an image of a container. And then stream that output to the Docker client, which sent it to our terminal. So that's the steps we got to get to here. And you can see it says to try something more ambitious, you can run an Ubuntu container using docker run-it ubuntu bash, but we're going to do that in a second with something else. So our first container that we're actually going to run is Alpine Linux. So Alpine Linux is a lightweight version of the Linux distribution. So we can get an actual Alpine Linux container and run whatever we want inside of it using Docker. So the way you do that is by doing docker pool alpine. So what that does is it tells the Docker tool to pull from the Docker Hub the Alpine image. And then it saves it to our system. So if you are on the Google Cloud Shell, it saves it to your Docker images, which will get deleted after you close the Cloud Shell out. So if you wanted to come back in here and try again later, and you're like, hey, where is my Alpine image? It's because the Google Cloud Shell deleted it after you closed your session, and you'll have to pull it down again. If you're running this on your own machine using your own installed version of Docker, you'll have this until you decide to delete it. So now we can see the images we actually have. So if you type Docker images, it'll show you a couple of things you have: the Alpine image, and then the hello world image, likely. I assume it shows hello world there. Slide doesn't show hello world, but you can see that it shows it up there for me. So this is a way to see all the images that you've pulled down to your system, or that you have built, which we'll talk about building in a second. And so now let's run something more interesting than just running the hello world image. So what we're going to do is we're going to run the Alpine Linux container and actually pass in a command. If you've never used a Unix system before, the ls-l is telling it to list the files in the home directory and include the long form, which includes details like permissions, ownership, and timestamps. So docker run alpine ls-l, and if everything worked correctly, you'll get the output of the root directory of the Alpine image container. If anybody runs that and doesn't get that, just raise your hand and I'll send somebody over to talk to you. So that's a really simple example, but think about using this paradigm, what we can do on top of this, right? So that's a simple example where all we did was locate the requested image, we started a new container up using that image, and then we executed the provided command. But if that's what we can do, there's a lot we can do by passing in a command to a given image. So if you want to try it out just to prove that it's really doing that, you can run on that Alpine image any Unix command you can think of. So if you've never used Unix before, a good example of one is pwd, which is going to show the full working directory, which is just that root directory. I guess that's kind of boring. Let's find out who we're running as. So it tells you that we're running as root. Anybody have a more interesting Unix command for me to run?
What's the one that deletes recursively?
Let's not do that one. Actually, though, that's probably pretty safe in an image, right? Because it's going to destroy that specific container, but your image is fine, and there's no actual damage to your system. After we're done, maybe we'll try that out. I mean, it's on Google server, so it doesn't hurt me no matter what. So, you have a command? Yes, good idea. Ooh, does Alpine have the apt get system? Depends on that. We'll find out. It could not find the apt get system. For those of you who don't know what that is, apt get is a package manager on, oh, I have to run it again, Google.
Try running top.
Top? What is it? So apt-get is a package manager system in some Linux distributions, and it has apt-get-mu, which just prints out a have you moved today thing. So just a cool little thing. Any other Unix commands to run in our Alpine image?
Try top. That should be running.
fancy. We've got nothing really running.
Wow, it's just one thing.
And then one thing.
So I typed clear. If you typed in that top and it messed up your screen, I typed in clear to wipe the screen. So let's talk about the containers themselves. They're fast. Each time the Docker client runs, the command in our container runs and then exits immediately. Booting up a virtual machine, running a single command like ls or top or trying to run apt get moo is slow because starting the whole virtual machine is going to start everything up. But in a Docker image, a Docker container, you're sharing those resources, which means it's fast to start up and it's not a big deal to run that single command and then exit. So let's get interactive, and instead of doing these single commands, and I kind of gave a preview of this by running top, let's actually connect and run inside of that Docker image. So if you type docker run -it, which says let's do it interactively, and then the name of your image, which is, we're still doing this Alpine, and then the name of the command, which we're going to do /bin/sh, which is going to start our shell. So we're telling it we want to run interactively, and then we're telling it we want to start a shell, which, when we hit enter, is going to actually give us a shell inside of that container. So if I type ls-l, you'll see it's the same result we had a few moments ago when we just did docker run alpine ls-l. But now we're actually here, so we could do something if we wanted to. We could change the home directory and then make a directory called Kurt, and then now we've got a directory. So you can go in here, you can make changes, but when we leave this container, all those changes are going to be gone. So we'll talk about that in a minute. So the cool thing is, like I said, you're connected now. You can do whatever you want. We could recursively remove the file system. We'll try that when we're done. I want to see what happens. So how do we exit? You can type exit out, and that'll work. Or you can just hit Control-D to exit as well. And then I'm going to hit clear again to make things a little bit easier to see on my screen. So anybody have any questions or any problems running through these commands themselves? Cool. So running a container of Alpine Linux is all fine and well, but it's kind of just a novelty at this point, right? There's nothing we can actually do with it. So let's run a real sample web application. So what we're going to do is we're going to run a sample application from MLH that they wrote, and I'm going to show you guys how to do that. If you want to find the source of the code, the source code, not source of the code. Source of the code is MLH. The source code is on GitHub, which you can get to it. I believe the first blue link up there gives you just a zip file of the code. And I want to say the second link, well, the second link in black is the actual GitHub repo. And then the third link is if you want to see this running on just the actual live web before we run it on our container. So don't type this in yet because it won't work depending on the system you're on. So if you are running an actually installed version of Docker on your local machine, you have whatever operating system that supports it, you are free to type this command in exactly as is and it'll run. If you are on Google Cloud Shell, things are a little bit different. So the way we're actually going to preview on Google Cloud Shell, which I'll show you what we're going to do, is if you go to right here on your command window, and if you don't see this button, it's because you probably need to close your hamburger menu. So go up there and click close, and then the console should take the full screen. You see this web preview button. If you hover over it, it says web preview. Google Cloud Shell actually allows you to connect to a port on your VM and see whatever is running on it. And if you see here, it says preview on port 8080. You actually only have a couple of options, 8080 to 8084, but that is plenty fine for us. So if you are on your own Linux or Mac or Windows 10 Pro edition, type in that command and run it. If you're on Google Cloud Shell, we're going to change one thing about the port numbers. So we're going to do docker run. We're going to do --name, which names our image, and I'll show you how that's useful in a second. And we're going to name it static site. Then we're going to do -d to enable detached mode, which means it'll keep running after we exit out. and then we're going to do -p and tell it which ports to run on. And this is where things get a little bit different for you on the Google Cloud Shell. So if you're on the Google Cloud Shell, we know that what we need to put it on is port 8080. So you have this concept of ports, for those of you who might be unfamiliar with ports on a machine, that you can connect to, and then a specific application connects to those ports. Well, on our specific image container, what's going to happen is the static site is going to be looking for connections on port 80. Port 80 is the traditional HTTP server port. But on our Google Cloud Shell, what we actually want it to appear on is port 8080. So what this -p does is it lets us tell us that we want it on port 8080 on our machine, but we want to connect port 8080 on our machine to :80. So that's going to tell it to connect 8080 on our machine to 80 on theirs. And if that's a little hard to see, let me see if I can zoom that in. I can. Wild. Does that make it a little bit better? So that's how you're going to run it on the Google Cloud. If you do 888, you can do it there. And then you're going to type in the name of the image. So just like we did the Alpine or the Hello World, you're going to type in MLH-ACKS/docker-static site. And so what MLH has done is they've uploaded the Docker static site to Docker Hub. And so what this is going to do when I press enter is it's going to download it from the Docker Hub and run it. Does anybody need this command for any longer? Cool. So, oh no, okay, so it says it couldn't find it locally, which makes sense because we don't have it locally. And so now it is going to Docker Hub and it is downloading it. And it's a little bit bigger than the source code itself because it's more than just the source code, it's also an image. And you can see that we downloaded it. It gives us the hash of it so that we could say, hey, is this the real live hash, or was it corrupted or possibly maliciously changed? The Docker Hub's pretty safe. And now it is running on our actual port. So on Google Cloud Shell, you'll go to preview on port 8080. Oh, okay, so let me talk about what actually happened first. So we didn't have to type Docker pool because it saw we didn't have it locally, like I said, and it pulled it down from the Docker Hub. We're running it detached. We told it which port to run on, and we named it, which I'll talk about naming it in a second. And then on Google Cloud Shell, we exposed port 8080. On your own machine, you probably exposed port 8888. So now if you're on your own machine, you can go to localhost :8888 or whatever port you typed in for that first number. If you're on Google Cloud Shell though, you see over here you're going to click that web preview button and click preview on port 8080. And it'll take a little second to load, but look at that. We are running our first web server inside of a Docker container. Yeah, ooh.
This is totally wild.
Wild. So does anybody not have this? Because we can send somebody over. Isaiah?
I haven't done any of those steps.
Oh, well, of course you don't have it. You don't?
I put the wrong part.
Okay. So I'll show you how to fix that in 1 second, just as part of the thing. So if you put the wrong port or you're just done running it, all you have to do to shut it down is stop it. So, oh, I don't want to leave. How do we know what is running? The way you know what is running is Docker PS. Oh no. Come back to me. There we go. So Docker PS, if you're familiar with PS on a Unix system, lists all the processes running. But with Docker, it's going to list all your Docker containers running. And you see that we have a list. It's a little bit messed up printing-wise, but you can see that the container ID is this. It's this image. It's got this command set to run, when it was created, how long it's been up, the ports it's on, and then its name. So if you want to shut it down, you can type docker stop, and then its container ID. So 655, and it's going to be different on your machine than from what I'm typing, so you actually need to run Docker PS to see it. And you hit enter, and it's going to tell me in 1 second it's going to print out the name of the Docker container, if I typed it correctly. Yep, I did. So I stopped the Docker container, and now I can actually remove it So if I type Docker images now, you can see that I've also now got this MLH hacks Docker static site. And I could clean up after myself by typing Docker remove, because typing stop did not actually remove the image from our system. So let's go ahead and do that. I was hoping that if I hit tab it would autocomplete, but it did not. So real quick, it just deletes the actual container there. So now that we've done that, if you wanted to run it again and possibly make a change, you can just hit the up key to go to your command line that you previously entered to start it. Scroll over to whatever you want to change, if you want to rename it, if you want to change ports or the actual image, and then hit enter again, and you'll see it just goes and creates it. And if I go here and I refresh, we're going to have it still running. Well, not still running, now it's a new image, right? So this is a good example of why naming it is useful. So instead of typing out that long, annoying ID, I can just type docker stop static site. And slowly but surely it will happen. So if you go through the effort to name your containers, it's easier to do. If you don't name your containers, Docker will name them for you, and they usually have some funny names. It's like adjectives and famous computer scientists that they mix together to randomly name your Docker containers, which was super confusing to me the first time I stumbled upon Docker, and I was trying to figure out why anybody named it Sleepy Feynman or something like that. So, anybody have any questions so far before we move on to making our own Docker, something a little bit more complex? All right, so how do we create our own actual image? Because all we've done so far is run from the Docker Hub. So let's find out by making an app that displays cat photos courtesy of BuzzFeed. So this one is going to require a little bit extra if you're running on the Google Cloud. If you are running on your own machine, all you have to do is go to that mlh-local.host/docker-flask-source, and that'll download the source code for you. If you are on Google Cloud, it's a little bit more annoying because there's not an easy way to just get that zip. So what we're going to do is we're going to type git clone, because this is all on GitHub, right? MLH open sources all of the code and all of the slides and things for this. So if we type git clone and then you type in this URL right here, and I'll mirror it on both screens, what it'll do is it will actually pull down the source code for this workshop. So that is https://github.com/mlh/mlh-localhost-intro-2-docker. So go ahead and type out that. If you weren't here for our Git workshop, or you've never used Git, Git is a source control tool that what this is going to do is it's going to go to GitHub. GitHub is a big website of Git repositories, and it's just going to copy that code down onto our machine. So if you typed it correctly and you hit enter, it'll tell you that it's cloning it into a directory called MLH Localhost-intro-to-docker. So if I change directories by typing cd, and I hit tab after I type MLH because I don't have anything else in this home directory, and I go in here and I type ls, you can see that there is the source code for our static app. There's a readme, but what we care about is that Flask app. So if you type cd Flask app and hit enter. Anybody have any questions or problems downloading the source code, which I think my head might be a little bit in the way of that. All right, so what we're going to use to actually build our own container, our own image for containers, is Flask. So if you've never heard of Flask, it is a Python web framework, which makes it easy to build web applications by just providing you a standard way to do it. But to understand what we're going to do right now, you don't actually need to understand Flask. So what I'm going to do is I'm going to explain a little bit about what's going on in these Flask files. So if you type ls in the Flask app directory, you can see a couple of things, and I'm going to type nano app.py. So if you have a more preferred text editor, feel free to use that. If you've never done text editing on the Unix command line, nano is a nice way to do it. You use the arrow keys to navigate, and you have your control commands at the bottom, which you can use to exit. And that that caret there just means control. So what we're looking at here is some Python code, which is saying that we're importing the Flask libraries in a random library. We're defining our app, defining a couple of URLs for images, and then right here is where all the actual work is going on. So you can see there's not a whole lot actually going on here, but we're annotating this function right here and saying that our route, which means that the route for the single slash, which in a website is just going to be your home page. If you went to acm@uc.org, that initial route, if you don't type /c or something like that, is going to be your index. So we're defining our index function with that route right there. And we're saying that our URL is a random choice of those images. So we're using the Python random library to just randomly pick one of those 3 Docker cat pictures. And then we are returning render template index.html, and we're setting a URL. So remember this URL being equal to URL. I'm going to talk about that in 1 second. And then we are saying that when we run this app, just run this on the that IP address, which is your local host. So this render template function is going to look for index.html, which is the next file I'm going to pull up, and it's going to pass in this URL. So what does that mean? And we're going to pass over the requirements since I'm talking about that. Oh, it doesn't exist. I am looking for templates. So here we go. So I'm looking at the index.html file in the templates folder, and it's got a couple of HTML tags that says it's HTML. It's defining the head, but what we actually care about here is the body. So this is the body of our actual page. We're saying that we've got a CSS class called container. We've got text of size header 4 that just says cat gif of the day. And then we've got this image source equals curly brace, URL, curly brace. And what that's doing is that render template function that we saw on the last file I pulled up is going to this, and it's looking for this argument called URL, and it's plugging it in right there. So in that URL curly brace, it's just going to plug in whatever URL was randomly selected from that list. And then we're also going to appropriately source BuzzFeed for our images. The other thing to mention is we have that requirements.txt. Not readme, don't care about the readme. And all this does is it defines a version of the Flask app for us to use. Then the last thing we're going to look at is the Docker file.
Sure.
Yes?
What is there a / at the end of the image tag? That's not significantly correct.
I didn't write this code. File a pull request.
What's that?
File a pull request.
Is it on
It's on GitHub. The link was up here.
I don't really like text, but it's text.
Where?
Under top
The
of
code.
Oh, I don't know. I assume it's a picture of text.
Oh boy.
So, what our Docker file is doing is it's defining a couple of base rules for the Docker image to run on. So what we say is that we've got this base image here, which we're running on Alpine 3.5, which says we want version 3.5 of that Alpine container we were running on a bit ago. We're defining some of the dependencies we need. So we know that in order to run Flask, we need Python 2. So it adds and updates the Python 2 pip, which pip is the package manager for Python module manager. It installs a couple of Python modules that are needed by the app, which are defined in that requirements.txt, and gives it instructions to install those. And then it just copies the files that are required to the appropriate directory, tells the Docker container, not our host machine, but the Docker container, to expose port 5000, and then it sets our actual command. So this is why we didn't have to type a command in when we ran the static site before, because it was defined like this. And all it does is it says run Python and run the app.py file that we just put in this directory. So your Docker file is the core of actually starting up the Docker image for you, giving it the rules on this is what the background image should look like. We want it to run on Alpine Linux because the code by itself isn't going to accomplish a whole lot. We need something backing it, which is going to be that Alpine Linux. So we're going to build it. Before I get to building it, does anyone have any questions about the actual repository and the code? Cool. So I'm going to clean things up. If you are in the MLH Localhost source directory, so if you're on your machine, you've expanded the zip file and moved into it, or if you're on the Google Cloud, you're in this Flask app, you want to be in the Flask app directory, which if you type pwd, it should look something like this with your name there instead of mine and probably a different machine. Well, certainly a different machine, right? So what we're going to do is we're going to tell the Docker command line tool that we want to build an image, and we're going to give it the -t, which I believe tells it, I don't actually know what the -t does. Can't win them all. So what does the syntax of this command actually mean? So like I said, I don't know off the top of my head what the -t command means, but we're telling it the name we want. Oh, this is right. You notice I didn't follow the instructions. Replace the MLH hacks with your own username. So when you created that Docker Hub account, you created a username, and so mine was Kurt Lewis. Yours is probably not Kurt Lewis. And then name it flask-example. And then the last thing you're going to pass it is a single period. And that just says we want to build the directory we are in right now. Once you've typed all that out, you'll hit enter. You'll see that it pulls down the Alpine 3.5 library, image, not library, installs some things, and then you can see right now that it's running that in upgrade pip. It's handling some of the dependencies for that Flask app, and now it has created Kurt Lewis /flash-example:\latest, which just says that that's the latest build we've built. So now let's run it. This is the same thing as before, in that if you're on the Google Cloud system, you're going to have a slightly different command than what's up here. But if you are on your own machine, you're free to run it as you want. And remember that you're going to replace that MLHX username with your own. So I'm going to type clear, and then I'm going to type docker run, tell it the port information, which is going to be 8080:5000. Now, why is it 5000 this time instead of 80? Any answers? Yes?
Because 5,000 is the port you opened on the Docker.
Yes, that's exactly correct. In the Docker file, we opened up the port 5000 right here instead of opening up port 80. So type that in, type your username, not MLHX. And what it should do is it should tell you that it's running. Notice we did not pass the -t flag this time, so instead of running it in a detached mode, it is running and it has taken up our command line. But now if I go to that web preview and I click preview port 8080, we're going to get to see a cat GIF of a particularly mischievous cat. So, and if you refresh, it should give you a different cat GIF. But remember that there were only 3 in the source code, so you're not going to get a different one every time. So once you've seen all 3, there's not a whole lot more to see. Now we've got our cat GIF site, and as much as we like cat GIFs, we want to stop it. So the way you're going to stop it is by pressing Control-C, and you'll see it'll stop. In my case, I actually have to press it twice because the formatting's there. And so now what we're going to do is we're going to host that Flask app on Docker Hub. So that instead of having to build it on every machine we want to deploy our cat-gif website to, because you're probably going to want to deploy that website on a clustered instance somewhere that can really handle the load it's going to get. We want to upload it to Docker Hub so that all those machines can just pull down that image. So the first thing you need to do is Docker login, which, fingers crossed, yes. I am already signed in, which is great because I would have to pull up my password in front of all of you if I wasn't. So you'll type Docker login, you'll enter your username and your password, and it'll tell you that you're logged in. I'm not going to do it because I used a randomly generated password, and so I would have to pull it up and all of you would get to see my password. So I'm already signed in, but if it's you, you'll need to actually sign in. And remember that in these slides, your username is not MLH Hacks. Your username is something different. Anybody having problems signing in? All right. So now we're going to do the opposite of pull. We're going to push. So again, replace MLH Hacks with your own username. In my case, it's Kurt Lewis. And then Flask example. So what this is doing is it's saying, hey, I want to push to the username, my username, and I want to push the image Flask-example, which is what we just built. And if you hit enter and things are all good, it's going to give you some cool graphics while it pushes it up. So if your push was successful, now you can go to Docker Hub, hit F5, and you can see now that I've got a repository. And already one pull. Look at that. Anybody having problems? All right. So let's talk about Docker Cloud. So Docker Cloud is one way to deploy and manage your Dockerized applications. It's optimized for using Docker. It makes it easy for new Docker users. You can manage it, deploy it, and you can do anything you want if it's just a single container application or it's a distributed microservice like I was talking about earlier. And it lets you deploy to any cloud or an on-premise infrastructure. So it's nice. And as a college student, if you have not used it yet, you get that website will give you $100 free in Amazon Web Services credit. Kurt, I don't know how to use Amazon Web Services. We've got you covered. Andrew back there gave us a workshop on using AWS for one of our previous meetings. So we've got all the resources, the slides, the video for that online on our GitHub. If you go to the ACM at UC website, you can find a link to that. So MLH has asked that we do a quiz. I will do it along with you guys, though not on the big screen. And if you will do that for me, and then once you have done the quiz, raise your hand, and I will come around and give everybody who wants a sticker. And that we have a couple of different options here, and there's enough for everybody to have one of each. So if you're still taking the quiz, don't worry, keep doing the quiz. If you want to join the Docker student community, they'll give you access to a couple of free things. They give you promo codes and things like that, so it's a good opportunity. I believe when you checked in, MLH is going to send you an email to this link. Otherwise, it's right up there. And like I said, all of these slides and things are going to be available after the meeting. You can join the Docker community Slack team, so if you're actually using Docker and you want to troubleshoot, you want help, there is an online Slack team where there are experts there and people more than willing to help you out. You can become a Docker campus ambassador. So if you said, wow, this was a great time, I want to learn more about Docker, and you go out and you do it, Docker will give you swag and things to distribute and increase knowledge of Docker on campus. And then the last thing is that if you really love Docker and you want to fly to San Francisco, you can go to DockerCon on June 12th to 14th. I'm sure they have student discount tickets. You just have to pay for your flight. So that is the intro to Docker Localhost. If you have any questions, you can come up and talk to me. If you have anything about ACM, you can come talk to me. Anything at all, as always, come talk to me. So thank you everybody for coming out. Grab more pizza, grab stickers on your way out. Don't grab a ton though.